See any cell phones? Multiplying and dividing rational expressions. So Xavier, headphones out, please.
Okay.
All right. What does the word rational mean? Anyone remember what does the word rational mean in math class? Fractions. Multiplying and dividing rational expressions. All right. So first we're going to look at multiplying. So if I have the fraction 2 over x multiplied by y over 5, how do I multiply fractions together?
Cross.
You go straight across. So you're going to take the top and multiply it by the top. What do you get? 2y over 5x. So when you multiply straight across. All right. Divide. Dividing fractions. So let's say we had 2 over x divided by y over 5. Or, there's another way to write that, or they might write 2 over x divided by y over 5. Two different ways of writing the exact same thing. Yeah, fraction over a fraction, not so fun. So 2 divided by x divided by y divided by 5. Anyone remember how to divide fractions?
You do that butterfly method?
Yeah, so some teachers did the butterfly method. Now, I'm going to say I don't like the butterfly method, and here's why. It's confusing because a lot of students don't know which thing goes on top and which thing goes on bottom. That's what I don't like about it. Has anyone heard keep it, change it, flip it?
Yeah.
Yes. That's my favorite because it's the same every time. So we're gonna write keep it, change it, flip it. So the keep it part is the first fraction. Keep the first fraction. So 2 over x, you keep it. The change it is the division sign. What do you change it to? Multiplication. Change it. What do you think flip it means?
5 over y.
Yeah, flip the second fraction so it's 5 over y. We just took this division problem and we wrote it as a multiplication problem. That's what we did. So now it's only a multiplication problem, and how do you multiply? Straight across. So 2 times 5 is 10. X times y is xy. I put a dot for times. If you want to put a little x for times, you can. Okay. So the biggest thing about these notes to remember is that divide means keep it, change it, flip it. That is the big takeaway from these notes. Does anyone remember the big takeaway from Thursday? It was 2 words. We summed it up in 2 words. One starts with an F, and the other starts with a C.
Fraction.
Not fractions. Flip it. Not flip. That's from today.
And you trying to
wait, what were the letters again?
The first step on Thursday starts with an F. The second one starts with a C.
Factor.
Factor. Factor, then
Change.
not
Combine.
change. Not combine.
Create.
Not create.
What was the second letter?
Factor, then
Factor,
with CA.
Compromise.
And
No.
C.
Calculate.
No. Factor cancel. That was the takeaway from Thursday. Do you guys remember doing that on Thursday?
No.
You factor, and then tops and bottoms canceled to make a 1, right? 5 over 5 becomes 1. X over X becomes 1. X plus 7 over X plus 7 becomes 1. So on Thursday, the big thing was factor, then cancel. Factor, then cancel. Today we're going to remember that. We're still going to say we are mostly factoring and canceling, but in the midst of that, we might have these problems where we have to keep it, change it, flip it. So we're taking those factor cancel problems and we're making them a little bit more complicated. Okay? Factor cancel. All right. Here's some examples. You ready? Example 1. We have 3x over 5, and we are going to multiply that by 30 over 18x squared. 3x over 5 times 30 over 18x squared. Now when we look at this problem, I see a 3 and an x written right next to each other. What operation is happening between the 3 and the x? Multiplication, okay? I see this dot right here. What does that dot mean? Multiplication. So I see lots of multiplication on the top. If I look at the bottom, what's happening between the 18 and the x squared? Multiplication, right? Squared, multiplication. And then I got the dot. What does the dot mean? Multiplication. So we have from left to right, I can see lots of multiplication happening. What about from top to bottom? What's the operation there? Division. Okay, so we have lots of multiplication and lots of division. What happens between multiplication and division? They cancel. Okay, so when you look at this, it doesn't matter where the tops and the bottoms are. You can still cancel tops and bottoms, so numerators and denominators, to make 1s. So when I look at this, I see a 5 right here, and then I see that 5 goes into 30. Everyone see that? So I'm going to divide out 5 from the 30, and I'm going to get 6. I'm going to divide out 5 from the 5, and get 1. So what I just did in this problem is I said 5 divided by 5 makes a 1, and I can cancel it out.
So you don't have to multiply across?
Well, you don't have to. What I would say is don't multiply across first thing because your numbers get really, really big.
Yeah, because
Then you gotta simplify it.
A little bit easier on these if you make the numbers a little bit smaller first, because 3 times 30 is 90, right? That's a big number. 3 times 6 is 18. That's a little bit easier to simplify, isn't it? Yeah, that's a little bit easier to simplify.
you're still going to get the same number.
Yeah. Okay. Does anyone see a number you can divide out if you have a 3 on the top and an 18 on the bottom?
3 and 18, which is 6.
Yeah, so 3 goes into 3.
Oh, wait, yeah. 1.
1 time. 3 goes into 18.
6
times, okay? Let's maybe write down what we have now. So what do we see that we have left over on the tops?
6 over 6.
I have a 6 on the top, right? 6 right here. What else do I have on the top over here? An x. So I'm going to say on the top of this one I have a 6x. Does everyone see where I got that from?
Yeah.
So I had a 6 from right here. And then over here I had a 1 there, so I'm kind of ignoring it because 1 times anything, it doesn't really make, the 1 doesn't make a difference, but this one still had an x. So I wrote down all the tops, 6x. What should I write down for the bottoms?
6x squared.
6x squared. Okay. Do you guys see any other canceling I can make?
Yes.
6 divided by 6 makes 1. What about x over x squared? Be careful.
1 over x.
1 over x. Why was it 1 over x and not just plain old x? The extra x is on the bottom. That's good. So we can say we got 1 up here and 1 down here that cancel out, and it left 1 on the bottom. Okay, so that was a multiplication problem. It's almost identical to what we had on Thursday. There's just 2 fractions instead of 1. So we're still canceling. We're still saying whatever is on the top and the bottom that's the same, you can divide it out. It divides out to make a 1. Okay, example 2. All right, this one's going to be a lot trickier. So x squared minus 1 over 4x and then divided by x squared minus 5x plus 4 over x to the third minus 16x.
Where do you come up with these numbers?
I have a little sheet right here.
I don't know what to say.
You're like, well, she just made that up off the top of her head. I didn't know. Okay. I see a division sign in this problem, so what should I do very first thing? Keep it, change it, flip it. Keep, change, flip it.
KCF. No.
KCF.
KCF. It's math.
KFC?
It's math, not chicken.
See? I told you.
Marquis got a chicken.
Keep it, change it, flip it. Okay.
No, guys. We all that big shit. You know.
What's happening between the x squared and the 1? It's being subtracted. Does subtract and divide cancel?
Nope.
What's happening between the x to the third and the 16x? They're subtracted. What's happening between the x squared and the 5x? Subtracted. What about the 5x and the 4? They're added. So we have a lot of adding and subtracting, and we also have some dividing. Do we have things that will cancel right now? No, those are not operations that cancel out. So from Friday, what do we have to remember next? Or from Thursday? The 2 words. What are the 2 words?
Factoring, cancel.
Factoring, canceling. Factor, cancel. So now we got to factor this. What type of factoring is x squared minus 1? Difference of squares. 2 sets of parentheses. One with a plus, one with a minus. Anyone know what those factors are? X plus 1, x minus 1. Does the 4x on the bottom factor? No, and it's already written as multiplication, isn't it? 4 times x? Okay, that one's ready. How do we factor the top of this one?
You sure do. Oh.
It's not. It's only got 2 terms though. It's not. It doesn't have 3. Diamond is definitely the bottom, right? That's a diamond. Should we do the bottom first?
Yeah.
Okay, since we know what to do. So we're gonna say whatever multiplies to 4, but adds to
-4.
-5.
I mean, negative 4. I was right with the numbers. I was doing 4. Yeah, -4. -1 and -1.
There we go.
-4 and -1.
So x minus 4. We just came back from spring break. Our brains are not really mathy right now. Okay. Mathing is hard after spring break. Okay. Now we got to factor that top part. We know it's not a diamond problem because it doesn't have 3 terms. What type of factoring do we always check for? GCF. Is there a GCF?
Yes.
I see one.
I see one too.
There's a GCF of x.
Yeah.
Okay. So if we look at the top, if we take the x out, what's left over?
So you got x squared.
X squared
Minus 16.
minus 16. Okay, what do you see then? What about this part?
Difference of squares.
Difference of squares. So we had a GCF of x. I'm going to go ahead and write that. And then we have difference of squares. So we got 2 sets of parentheses, one with a plus, one with a minus. X squared minus 16 is what we're factoring now. Yeah. X plus 4, x minus 4.
Okay. I see.
So now if we look at the problem, do you see how we have something multiplied by something?
Yeah.
Multiplied by something, multiplied. Do we see all the multiplication happening now? Okay, so now that we have lots of multiplication and we've got division happening, now can we cancel things? Yes. So things that have been multiplied can now cancel with things that have been divided. So we're looking for tops and bottoms. We just did the factoring, now we do the canceling. What top with what bottom should divide to make 1? So x minus 1 divided by x minus 1, those divide out to be a 1, they're gone.
X minus 4 and x minus 4.
X minus 4 divides out to be a 1, it's gone.
Okay, what about x and 4x?
What about the x and the 4x?
Would that cancel out to make 3x?
No, but you have the right idea.
Or just 3?
Four squared?
Just 3.
We don't need to factor in because they're multiplied together.
It'd be X, right?
Four squared. Four squared, right?
Wait, when you cancel, what's the thing that's identical? Between the x and the 4x, what's exactly the same on top of the x? So if I say 1 on top cancels with 1 on bottom, they divide out to make a 1, so they're gone. And that just leaves the 4 on the bottom.
Wait,
So we said we had an x on the top
I was wondering why you did the X on the outside. No.
and the x on the bottom. We were able to do that because see how this is x times other things? And this is a 4 times an x.
Okay.
And then a top and a bottom means that it's division. So since they were multiplied and we divided, those operations cancel each other out. Okay. So what do we see? Now we have a multiplication problem. How do we multiply fractions? Straight across. So what do we see when we go straight across the top?
We're gonna rewrite it.
X plus 1 times x plus 4.
X squared plus 4.
You actually typically don't have to multiply those out once you're done.
Oh,
X squared
okay.
for 5x plus 4.
And then what do we have on the bottom?
4.
4.
4.
We are going to call it good right there. We're going to be like, yep, done. That's it.
So I need to.
We factored, we canceled, we're done.
So you won't have to like.
So that's the simplest form.
That is the simplest form. Yep. All right. Now, it is possible. There's different teachers have different schools of thought on like what the most simple form is. Because a lot of you guys wanted to FOIL the top. You wanted to say that this problem was x squared plus 5x plus 4. Now, if you're doing this problem and you're taking like the NC final exam, for instance, you might get this as an answer, but all of your A, B, C, D, your answer choices might have the final answer FOILed out. So then you would have to say, oh, this matches up with the answer that says x squared plus 5x plus 4.
So we can do it that way too.
You could do it this way, or you could FOIL at the top. For my test, both of those are going to get you full credit. Does that make sense? On a multiple choice test, you would just want to make sure that you could recognize that your answer really was the same as the other answer. Okay? Does that make sense?
So
Okay.
on your test, if we do it both ways.
On my test, you get full credit either way.
What
So
if
if I was you, I'd be lazy and do it this way and not multiply it.
What if we do both?
So now here's the question: what if you FOIL it and you FOIL it wrong? I gotta mark you down for doing something wrong. But if you leave it like this and don't FOIL it, you're good. Okay. All right. So the plan for today is we are going to do these little maze cards. I know, I love them so much.
Zombie things. Oh, not
All right, let's get started. Okay, so here's what card A says. So everyone on their sheet of paper should have card A written down. Right, Marquise? Right, Xavier? Card A? You guys, please.
We were multitasking.
We were not multitasking. You were just listening. All right, now this is a multiplication problem. So do we have to start off by keep, change, flip? No, we do not. So since we are not keep, change, flipping, then what is the only thing we are doing? Wait, what are the two words from Thursday? Factor, cancel. Factor, cancel. So these ones you don't really have to factor them because they're already written as multiplication, right? 3 times v, 6 times v to the third, they're already multiplied. So now we can just get to canceling. Do you guys see any tops and bottoms that would divide out to make a 1?
No.
6v.
Not just
and
completely.
3v.
Yeah, so what about the 6 right here and the 3 right there?
Yes.
You could divide by what number?
2.
2.
You could divide by 3.
3,
You'd get 2.
yeah.
You'd get 2. Okay. So 3 divided by 3 is 1.
You said 3 divided by 3 is 1.
And 6 divided by 3 is 2.
2.
All right, what else could we do? The V's. So we got a V on the top and we got V to the third on the bottom. What do we see?
V to the
1 and V2.
Yeah, so we're going to cancel this one with one of these, and it's going to leave 2 of them left. Okay, so this is a multiplication problem. How do we do multiplication? Straight across. So we have 1 times 3 is 3. And on the bottom, we have 2v squared times 7. 14v squared. All right, go ahead and look through. Tell us what card we're doing next. We are doing H.
I found it.
Oh shit.
Watch your mouth.
Maybe you said that friend.
I'm sending this to your mom.
Oh.
I'm recording.
No!
Ah!
It's not like she cared.
I don't even have I was raised
Does anyone see anything that could divide to make 1?
Yes, 3 and 3.
3 over 3, that's an easy one. Okay, that divides to make a 1.
X squared.
X squared and x. What about x squared and x squared?
Yeah, I'll do about it.
Yeah.
Yes.
Yeah, you could do that. Okay, x squared and x squared.
So
So we just have an X now.
So we just have an x, and the x just happens to be on the bottom, right? It's going to stay down there. Okay. Anything else?
We can divide this.
Well, divide
4 by
4 by
2.
2.
Divide by 2. Okay, so 6 divided by 2 is 3.
And 2.
Okay, so now we have a multiplication problem. What was left if we canceled out the 3 and we canceled out the x squared? What's left on the top?
0.
Is it 0 or is it 1?
1.
It's 1. Okay, when you divide, you make... when you divide the same thing by itself, what do you get? 1. Okay, so when we divide them out, we have a 1 left over. So on the top, we have 3 times... 3 times 1 is 3. You're telling me the answer. You're telling me the answer. All right, over here we have 2 times x is 2x. All right.
You know it. You know it.
Ah, I'm not getting lucky. Hey, I'm on sorry, guys. I thought you sitting over there.
You know it.
You just know it's out like that.
And country of
So these problems are divided. So what's our first step?
Keep changing.
Keep, change, flip. Keep it, change it, flip it.
So we keep 4 over 9.
6 and 4.
Pop it.
Okay.
Squeeze it.
So that's the actual problem we're doing. All right, don't say it out loud, but see in your group if you guys can like figure out what you should be doing. So don't shout it to the class, but you can talk in your group. Just don't shout it out to the whole class.
I just wrote 16 on it. And then I could probably simplify that.
You said 67.
Hey. It's human.
Oh,
You
yeah.
can do the 9
Because 12 times 5 is 60, and 45 divided by 5 is 8, 9, 10. 8, 9.
I'm confused.
Someone text me. Yo, you leaving today?
Anyone want to tell me one thing that could cancel?
The 6 and 10.
6 and the 10?
It goes to 3 and 5.
3 and 5. So 6 divided by 2 is 3. 10 divided by 2 is 5. Okay.
Mm.
Then you go straight across, right?
You could go straight across, or you could do some more canceling. Does anyone see some more canceling?
Oh, 9 and 3.
The 3 and the 9, yeah. Okay, what do we see now? You could, if you went straight across, what would happen?
You would
You got
have
12 and 45.
Yeah, you would have a 12 and a 45. You just have to keep going from there. Now, 12 and 45 are some big numbers, right? But if I do this problem without multiplying it straight across, if I do a little bit more simplifying, then I won't get a 12 and a 45, and I'll actually be done. So what do you see between this 3 and this 9?
1 and 3.
Yeah, so 3 divided by 3 is a 1. 9 divided by 3 is 3. So you get 4 into the 4th over 15. And if you had multiplied before you did that simplifying, you would have had 12 over 45.
Yeah.
And then if you recognize that, you can say, oh, those are both divisible by 3. And you'd get the 4 over 15, but it's a little bit easier to do it over here. All right, what's our next letter? J? All right, you guys feel ready to do them on your own? Yep. All right. Ooh, that's a weird jam. Okay, go ahead and work on them on your own. I'll be around if you need help.
Can I use the restroom?
Yes.
I drink too much water for this.
Have you seen the little boy, the video, like, why he was on the toilet? And he was like,
Right down.